Okay, so once again I've been asked to explain my working, so that's what this video is about. So let's just get straight into it. And the first thing is 3 to the power x is equal to 30 to the power x plus 2. There's nothing to explain here. This is just the question as stated. We are asked to explain what is 3 to the power x to the power 30 to the power x plus 2, and we want to simplify it. Okay, so this brings us to our second line, and that's 3 to the power x is equal to 3 times 10 to the power x plus 2. Well, there's not really anything to explain here. 30 is just equal to 3 times 10. 3 times 10 equals 30. It's just bog standard arithmetic. Nothing really to worry about here. And so this is where we get our first thing that probably needs explanation. So I want to talk about one of the slightly lesser known laws of indices. A lot of people are probably confident that when the indices are the same, when the bases are the same, you can just add the indices. Sorry about that. Okay, so that's one of the well-known laws of indices. One of the slightly lesser known laws of indices is when the indices are the same, you can multiply the bases. So a to the power b multiplied by c to the power b. Now note the indices are the same, so we can just multiply the bases. So that's a times c all raised to the power b. And let's just satisfy ourselves that that's the case. We've got let's use numbers. Let's say 2 to the power 3 multiplied by 3 to the power 3. And of course that's equal to 2 times 2 times 2. And that's multiplied by 3 times 3 times 3. Now, watch this. We take this 2 and we multiply it by this 3. And then we take this 2 and we multiply it by this 3. And we take this 2 and we multiply it by this 3. And then we multiply these together. So we've still got 3 2's and we've still got 3 3's. We've just rearranged them using the commutative property of multiplication, and the commutative property of multiplication is just a times b is equal to b times a. So all we've done is slightly rearranged this 3 times 10 to the power x plus 2 to be 3 to the power x plus 2 times 10 to the power x plus 2. And now you see this here is 2 cubed times 3 cubed, which is equal to 8 times 27. And this here is equal to 6 times 6 times 6, which is equal to 6 cubed. And 6 cubed is the same as 8 times 27. Let's check with the calculator. So 8 times 27 is 216, and 6 cubed is 216. Okay, I hope that's explained this line. So that brings us to the next line. Okay, so all I've done on this line is I've divided everything by 3 to the power x. Let's start with the line above, which we just explained. And now I'm just going to divide this by 3 to the power x. And then I'm going to divide all of this by 3 to the power x. So first of all, these cancel and we get a 1. Now here we've got 3 to the power x plus 2. So 3 to the power x plus 2. Remember the first law of indices, where the bases are the same, you just add the indices. So we can just say that's the same as saying 3 to the power x multiplied by 3 to the power 2. And 10 to the power x plus 2, by the same reasoning, is 10 to the power x times 10 to the power 2. And so this has been expanded out, and I'll put that instead of there. And now I can just cancel that 3 to the power x on the denominator with that 3 to the power x on the numerator, because it's all multiplied, and that gives us this next line. Okay, so that brings us down to this one here, which is basically just me writing what we've got left after we've cancelled out. So that's just 1 is equal to 3 squared. Well, we've got it up here already, haven't we? We've got our 1. And then we've got what's left here. And that is this line, except I've put the 10 to the power x here, again using the commutative property of multiplication. So that's all that's happened here. So nothing untoward so far. Okay, so now what I've done here is I've divided both sides by 10 to the power x. So we'll take the line above. And now we're dividing through by 10 to the power x. So cancel and cancel. And that leaves us with 1 over 10 to the power x is equal to 3 to the power 2 times 10 to the power 2. Well, again, that property where the indices are the same, we can just multiply the bases. So that's equal to 3 to the power, 3 times 10, all raised to the power 2. And that's all equal to 1 over 10 to the power x, which is what we've got down here. Okay, so the next line we have, well, all I've done is multiplied the 3 by the 10 again, and that's 3 times 10 is 30, so 1 over 10 to the power x is equal to 30 squared. So that's just arithmetic again, 3 times 10 is 30. And now this one, again, all I've done is arithmetic. 30 squared is 30 times 30, which is 900, so that's just 30 times 30, 0, 0, and then we add to that. We put 1 0 down because this is a factor of 10, and then 3 times 0 is 0, 3 times 3 is 9, 900 plus 0 is 900, and that's all that is. Now what I've done is I've divided by 900 and multiplied by 10 to the power x, which means we've got 1 over 10 to the power x is equal to 900. So now if we divide both sides by 900, we're going to have 1 over 900 times 10 to the power x is equal to 1, because 900 divided by 900 is 1. And now we multiply by 10 to the power x, and so then we've got 10 to the power x over 10 to the power x is equal to 10 to the power x. This 10 to the power x cancels with that 10 to the power x, and we're left again with 1 over 900 is equal to 10 to the power x, which is this line here. And now I've exploited the principle of equivalence, which basically says if A equals B, then B equals A. That's just called the principle of equivalence. Stands to reason if one thing is equal to another, then that other thing is equal to the first thing. If 2 plus 2 equals 4, then 4 is equal to 2 plus 2. Okay, so we've got 10 to the power x is equal to 1 over 900. So now we've got 10 to the power x is equal to 1 over 900. Now how do we get the x? Well, now we exploit the principle of logarithms. So log to base a of a to the power b is equal to b. That's basically what a log is. It is the inverse of the raising to a power. So that way we use the log to base 10. So log to base 10 of 10 to the power x. And what we do to the one hand side, we have to do to the other hand side, is equal to log to base 10 of 1 over 900. Log to base 10 of 10 to the power x then is just x. So x is equal to log to base 10 of 1 over 900. And the final step to get x is approximately equal to minus 2.954, that's just plugging the number into a calculator. It's simple. So we take 1 divided by 900 equals, and then we find the log to base 10, which is just using the log button on the calculator, not the ln, the log. And that gives us minus 2.954 to 3 decimal places, or 4 significant figures. And that's all there is to it. I hope you found that helpful. Enjoy your maths and have a good day. Take care now.